Hey there, everybody. Welcome back. We are going to start 4.4, ax squared plus bx plus c. Now, the reason why I like to do 4.4 before 4.3 is because the methods from 4.4 work for all of them, the way I teach it. If you look at how Mr. Blakely teaches it, he teaches doing by guessing. Take a look at it real quick. You come up with some trial numbers and you give them a try. You guess what goes in the parentheses. So you guess and you try things until you get it. Now, this is a perfectly valid approach, and it works really well when you're really skilled at this stuff. When you have more practice and you can start recognizing what groups together well and how to split stuff up, it's the faster version. Sometimes the numbers are really big, though, and it's not helpful. So I teach it by a method that always works. You don't have to be great at factoring or recognizing the greatest common number. We're just going to walk through my method right now. So what I do is what we're doing is this is a trinomial. It's called a trinomial. But we're going to try to do it by factoring by grouping. And the way we're going to do that is I'm going to split the b up into like a b1x and a b2x plus c. So we got to figure out how to get b1 and b2. b1 plus b2 has to equal the b. We got to figure out how I can split up b so that this will work well. And so this is how we're going to do it. A, find two factors that multiply to a times c. If they add to b, you're good. You're done. If not, try different factors. Now, this is very much like his trial approach, but where we differ is we're not going to just pick two random factors. We're going to do this by making a list. And we're going to start with 1 and a times c. Because 1 times a times c equals a times c. Then we'll try 2. Then we'll try 3. And I think you'll see how this list works. By making a list and following it sequentially to test factors, following it in order to test the factors, will tell us if this does not factor. I tend to write does not factor with capital letters. I will abbreviate that as DNF for does not factor. The way mathematicians say it is it's prime. It doesn't factor. So I think the best approach of doing this is show you an example. You know what? No, we're just going to go on, do a different problem. That one was prime. We're going to do a different problem. We already saw the table there. Let me make sure I got that right. I think I wrote a bunch of weird stuff here. 1 second. All right, so our first problem that we're going to do is 6x squared minus 13x minus 15. The video might have skipped for a second because I'm editing out a little block there. I want to do it later. So what I'm going to do is A times C. What is A? A is 6. B is negative 13. C is negative 15. So A times C is negative 90. B is negative 13. So I need two numbers that multiply to negative 90, but add to negative 13. I can always start with 1 and 90, but I need to decide which one I want to make negative. In fact, I'm always going to start with the number itself and a 1. Now, if they add together and I want it to be negative, the bigger number needs to be negative. So I'm going to put a negative on that one. These add to negative 89. Then I'll try raising this to 2. Does 2 go into negative 90? 90 divided by 2 is 45. So negative 45. These add to negative 43. Then I'll try 3. And I'm doing them on a calculator just to show you how you can do these quicker. Negative 30. These add to negative 27. Notice these keep dropping. They'll eventually hit negative 13 or pass it. Okay. If they hit the negative 13, we found what we're looking for. And I'll talk about if they pass it in a second. Let's try 4. Does 90 divide by 4? 90 does not divide evenly by 4, so I'm going to skip 4. 90 divided by 5. Yeah, 5 and negative 18. This adds to negative 13. That's what I'm looking for. I wanted negative 13. So this is going to be my B1 and my B2. If it skips the 13, skips the value you're looking for, but you're going in sequential order, it means it's DNF or doesn't, it's prime. As it is here, I'm going to take my 6x squared, my minus 15, and I'm going to split the negative 13x into a 5x and a minus 18x based on these two values right here. So a systematic table going up by 1. Now we can do grouping by pairs. This only has an x in common. Here I need to take out a negative. 18 is, I should end up with a 6 inside. So 3 times 6. I could factor out a 3 and I have a 6x and I have a 5. I finish grouping and I have x minus 3 times 6x plus 5. Now this is doable by the trial method. It's not too bad. Let's look at one that really just sucks. If you were to try to do the next one by the trial method, it could take you a really long time, if ever, to find it. Okay. So my A is 12 here, B is 59, C is 72. They're all positive, so what I'm going to have is positive. A times C, 12 times 72. Did I write down the problem I want to do? Yeah. 12 times 72 is 864. I need things that multiply to 864 but add to 59. So I can try 1 and 864, but we know that adds up too big. 2, 864 divided by 2 is 432. This is still too big. This is big by a lot. So I can try skipping ahead. Is this divisible by 6? It is. I'm going to skip ahead and not try 3, 4, 5. I'll try 6 and 144. That's 150. It's still going down, but I'm not to 59 yet. Is it divisible by 8? It looks like it's divisible by 8. 864 divided by 8 is 108. We're still too high. 10 doesn't go in. Maybe 12. Does 12 go in? Oh, shit. I know 12 goes in. It's one of the original factors. That's 84. It's still too high. We need something larger. So now I'm getting close to 59. I'm going to start going slow. Is 864 divisible by 13? No. Is 864 divisible by 15? No, it doesn't end with a 0 or 5. What about 16? Oh, I didn't try 14 yet. Is it divisible by 14? No. I'll show you it's not divisible by 15. It's divisible by 16. 16 and 54 is 70. We're getting closer. Is it divisible by 17? I don't think so. Is it divisible by 18? It's divisible by 18. And that's 48. 58, 68. This is 67. Still not there yet. It doesn't divide by 19, 20. Does it divide by 21? Does it divide by 22? Does it divide by 23? Does it divide by 24? Divides by 24. Oh, we're really close. Now the next number, if it's not 59, it's prime. So let's keep looking. Does 865 isn't divisible by 5? So it can't be divisible by 25. Let's try 26. It's 27. There it is. There it is. Look at that. We found it. Systematically going through an ordered list finds it. Doing trial pairs and don't do it trial by error, the method taught in the textbook. This is really hard to get. But now I know how to split up my 59x. My 59x splits up into 27x and 32x. Okay. So this is the benefit of doing the list rather than trial. Once you're good at doing trials, you can go fast and it'll save you time. But by that point, you're usually good at it and you'll develop trial on your own. We're going to go by pairing, by factoring. So 12x squared and 27x, they both have a 3x in them. This has a 4x and this has a 9. So 3x times 4x plus 9. If this works, my 4x plus 9 repeats. Okay? So what do I got to divide 32x by? If I divide 32x by 4, I get 8. I'll put an 8 out front. 8 times 4 is 32x. 8 times 9 is 72. I found my pairing. This factors into 4x plus 9 and 3x plus 8. All right. One more before I switch to doing all example video. What if I have 3a squared plus 8a minus 4? I need things that multiply to 3 times negative 4, which is negative 12. That's my a times c. My b is 8. They multiply to a negative, but they add to a positive number, which means the bigger number needs to be positive. Negative 1 and 12 add to 11. When I do negative 2 goes into negative 12 6 times. 6 and negative 2 add to 4. We skipped the 8. So this is prime. DNF. The list tells me right away. I don't need to try any more factors. It tells me right away this is prime. Now, the other way of doing this is trial by guessing by trial. So this is kind of like the idea that the book will try. It'll go, if this needs to end up as 2 parentheses, to get a 3a squared, I need one of these to be a 3a and one of these to be an a. That's the only way I'm going to get a 3a squared. The question is, what can I put here? Can I do plus 4 and minus 1? I could do minus 4 and plus 1. I could do plus 2 and minus 2. I could do minus 2 and plus 2. And the idea is to just start checking them and check what these add to. 4a minus 3a is 1a. And I'm looking for that. Look for 8a. If I do these two, negative 4a and 3a adds to negative a. Here I've got 2a and negative 6a is negative 4a. And negative 2 and positive 6 is positive 4a. All the combinations I tried don't give anything. Therefore, it's prime. This is the factoring by trial approach. Now, checking 4 pairs wasn't that bad, right? Checking 4 pairs wasn't that bad. Let's look at 12x squared plus 59x plus 72. Well, the first pair could be 12x and x. It could be 6x and 2x. It could be 3x and 4x. Then the number here was multiples of 72. I got to try plugging in 72 and 1. I got to try plugging in 36 and 2. I have to try a whole lot of factors. Let's see. Does it go by 3? Yeah. 3 goes in, let's see, 24 times. Does 4 go in? 4 is 18 times. No, it isn't. Yeah, it is. 5 doesn't go in. 6 goes in 12 times. 7 doesn't go in. 8 goes in 9 times. And then I would repeat. I'd have 9 and 8. So I would have to try all the combinations of this. 72 here, 1 here, then 1 here, 72 here. then 36 and 2, 2 and 36, all of those into 12, then all of them into 6, and then all of them into 3 and the 4 until I find what I'm looking for. That is a lot of combinations. 36 different combinations you would have to try just to find out that until you get the right one. We found it, didn't take as long. We found it in a quick, orderly manner. All right, I'm going to pause this video or stop this video, and we'll do another video with more examples. Peace.